All right, Algebra 3, Lesson 12. Lesson 12. All right, just so you guys are aware of what's going on the rest of this week, tomorrow we'll hit Lesson 13, Wednesday's Lesson 14. Your review is due on Thursday. We've known about that for a while now, right? All right, how important is the test? Really, really important, right? How many of you have already started working on the review? A lot more hands than last time. Very good. Okay, that's exactly what I want to see. All right, lesson 12 here, what we're talking about is angles and diagonals in polygons and in proof of the chord tangent theorem. Okay, so when we're talking about angles and diagonals in polygons, what a polygon is a closed geometric figure that's made up of line segments, right? And what's interesting about these is that we can split up a polygon into interior triangles. So you give me a shape and we can divide it into interior triangles. So this says find the sum of the measures of the interior angles of a hexagon. I want to show you that we have a formula for this, but why that formula works. Okay? I'm going to come over here. We're going to draw a hexagon real quick. How many sides does a hexagon have? 6. Has 6 sides. Now, it doesn't really matter. Let's see, 1, 2, 3, 4, 5, 6. If I want to find the interior angle measures of a hexagon, okay, what means we're trying to add up this angle plus 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 that angle. Okay, that's what we're trying to do. Okay, and we want to know what the sum of those interior angles are. Okay? Anybody have any thoughts about how to go about that? Okay? He might say, oh, well, that's, what do we know about each one of those angles in general? They're what? They're equal? We didn't actually say it was a regular hexagon, though, did we? No. Okay? So, what we're going to do is, I'm going to see if it'll let me undo all those little angles. And we're going to draw some lines. Okay? Now, I'm going to show you the wrong way to do this. Okay? Or do you want me to show you the wrong way? No, because you might get confused. Okay, so let's not do the wrong way. But I'm going to draw a line from here to there. Okay? I'm going to draw another line from here to here, and another line from here to here. Okay? I don't need to draw a line from this vertex or this vertex because those lines already exist, right? What do I have inside this hexagon now? What are those shapes? All right, so I've got one triangle here. I've got a second triangle here. I got a third triangle here, and I've got a fourth triangle there. Now, the reason that we drew all of those lines back to the same point is because every angle of each of these triangles is on a vertex of the hexagon, right? If, for some reason, the wrong way of doing it is to, I have to kind of show you the wrong way to do it in order to explain why it's wrong. Okay, so let's take that same guy and let's say, okay, I know that a hexagon or any polygon for that matter is made up of triangles. I'm just going to do this, right? 1, 2, 3, 4, 5, 6. I got 6 triangles there, right? Here's the problem. This angle, this angle, this angle, this angle, this angle, and that angle. None of those angles are out here, right? So I can't count any of those angles. See, here, every angle of every triangle is part of a vertex of our hexagon. You see the difference? Okay. Now, how many triangles do I have? 4. And how many degrees are there in a triangle? 180. So what I'm going to do is I'm going to do 4 times 180 to find out the number of degrees that are in a hexagon. Okay. How many is it? 720. But if I had done this, I would have done 6 times 180, and I would have come up with something much bigger, right? All right. So this is wrong. Don't do it. Yeah. Okay. Now, let's say we get to talking about a 14agon, and what is the sum of the interior angles of a 14agon or something like that. Well, now we need a formula because that's getting really hard to draw and draw all the little triangles. So we do have a formula, and our formula says this, is that we're going to take the number of sides of our polygon, okay, minus 2, and we're going to multiply that by 180. Do you notice that we multiplied by 4? Okay, a hexagon has 6 sides. We're always going to have 2 fewer triangles than we have number of sides. And the reason why is because this side and this side are never going to get counted. Okay? Does that make sense? All right, so if I have a decagon, I know I'm going to take 8 times 180. Right? So that follows, it makes sense. Okay? So hopefully you understand why I had to show you the wrong way to do it, okay, so that you understand it's got, now does it always have to be taken back to that particular vertex? No, okay, and now that you know the formula and why the formula works, all right, that should help you remember it just a little bit. All right, let's come back here. It says find the measure of each exterior angle of a regular octagon. Well, we're going from interior angles to exterior angles. So let's draw another picture. An octagon has how many sides? 8. Okay, when we start talking about exterior angles, we're talking about this. And whenever they start talking about this, notice that the wording will change, and they'll be more specific about their octagon. They'll call it a regular octagon. In this case, it has to be a regular for this to work. All right, so I don't know if they show you, yeah, they show you a picture on page 91 of, imagine a city block was shaped like an octagon, okay? Imagine the block on which you lived wasn't a rectangle or a square, but it was misshapen into an octagon, and you started at one corner and you walked all the way around, round being the operative word here. How many degrees would you have gone to get back to where you started? Effectively, even if it's a square, right, you're still walking in a big circle, right? You've made a complete circle. How many degrees are in a circle? 360. And so if I want to know what the individual angle is here, all of these are the same, right? Because we said it's regular. All right? So it doesn't matter what the polygon is so long as the shape is regular. All I'm going to do is I'm going to take 360 every time. 360 divided by the number of sides. Okay? And that's going to tell me what each angle is. What's 360 divided by 8? 45 degrees. Okay? So each of these, each turn that I make on a regular octagon, I am turning 45 degrees to keep on the street. Okay? Does this make sense? Simple formulas, but you don't use them all the time. Okay? So this is, you know, this would be the measure of each exterior angle. Now, the sum of exterior angles is always going to add up to what? If we were saying the sum, or all of the angles added up, are always going to add up to what? 360 degrees. All right. All right. This brings us to the chord tangent theorem. And the chord tangent theorem shows up on page 93. 93. Okay. All right, with question number 4, it says the chord tangent theorem states that the measure of the angle formed by a chord and a tangent segment that intersect at the tangent's point of contact is equal to 1/2 the measure of the intercepted arc. Below are 3 possible cases of this theorem. Okay. Question number 4 says prove case 1 of the chord tangent theorem. Now this is a long proofy type answer, so I'm just going to read it to you, but I'm going to try to make it make sense as I go. Okay, again, another reason why you want to watch a video okay, because not everything that you need is written up on the board. Again, I want to make sure that I've got everything on, because how embarrassing would it be to have another case where I wasn't recording any sound or any video. I can't tell you how many times that happened last year. It's really embarrassing. So the answer to question number 4 is a tangent to a circle is always perpendicular to the radius. All right, how many radiuses can I draw on a circle? 4? I can draw 4 radiuses on a circle? How many? I think I've heard an answer. I heard the right answer, and I've heard several wrong answers. 8? No, more than 8. Infinite. I can draw an infinite number of radiuses. Why? Here's the reason why. Because does a line have any width? No. As a line segment has a specified length, but it has no specified width. So there's really no limit to the number of line segments that I could draw around a circle. Okay? All right. So that being the case, if I have a circle and I have a tangent line, right, there is going to be exactly one radius that's going to meet that tangent line at a right angle, because there's an infinite number of radiuses. One of them is going to meet that point of tangency at a right angle. Okay? All right, so that in mind, a tangent to a circle is always perpendicular to the radius. So then, in our case down here, AC is perpendicular to OA. Okay? To radius OA. And the measure of angle BAC, that's BAC, is 90 degrees because a right angle or two perpendicular lines form a right angle. Okay? Then BXA, okay? BXA here that you see. All right? Well, what is a diameter? How does a diameter split a circle? How many degrees are in a circle? So what does a diameter split it into? 180 degrees. So we see here that a diameter in a tangent line is at 90 degrees, but a diameter creates an arc of 180 degrees, right? Okay, so the BXA, line BXA, arc BXA, intercepted by the diameter AB measures 180, therefore measure angle BAC is 1/2 of BXA. What we're saying is that the angle formed, okay, by my chord is always going to be 1/2 of the degree of the intercepted arc. Okay? That's our answer. So let's look at something else. Hopefully this will make a little bit more sense here in a second. Let's see. Now let's go on to another page here and see question number 5. Question number 5. We want to know if measure of BY, that's arc BY, that's this guy right here, is 44 degrees. We want to know what is the angle of YAC. We want to know what this angle right here is. Okay, so there's a couple of easy steps to this, right? Because what is all of this? 180 degrees. Okay, but what then is just that? 180 minus 44. Right? 136. All right, so we know that this is 136 degrees, which means this angle is 1/2 of that arc. Okay, so what do I need to do with 136? Divide it by 2. Okay, 136 divided by 2 is 68 degrees. There is another way of looking at it as well. Okay, now I'm going to erase this, but remember you have the video. Okay, we can look at it from the interior angle side of things. Right? If this is 44 degrees, then what is this angle right here? No. What's half of 44? 22. So if I want to know what the rest of this is, I know that the whole thing is going to be 90. I could take 90 minus 22, right? What do I get? I still get 68 degrees. Okay? Does all of that make sense to you guys? That's it. There's nothing else for me to give you, okay, other than to let you guys work. You guys come across some different questions. If you guys get stuck or stumped, okay, let me know.